All right, today we're going to be discussing perpendiculars and distance. We're going to be using all the information that you used from the previous 5 sections and put it together into this one. So these are the content standards and the mathematical practices we'll be using for this lesson. Previously, you've proved that 2 lines are parallel using angle relationships. Now you're going to find the distance between a point and a line and find the distance between parallel lines. We have one new vocabulary word, equidistant. Okay, let's look at the key concepts about the distance between a point and a line. The distance between a line and a point that is not on the line is the length of the segment perpendicular to the line from the point. So in other words, if we're wanting the shortest distance between this line and some point that's not on the line, the shortest distance is going to be the line that is the point and the line perpendicular to the previous line. There is one postulate, it's the perpendicular postulate. If a given line and a point not on the line, then there exists exactly one line through the point that is perpendicular to the given line. This you might add to your postulates page. Let's look at a real-world example. Now here they're going to be using doing a construction. So we've got a roof truss, and it's designed so that the center post extends from the peak of the roof, point A, to the main beam. And they want us to construct and name the segment whose length represents the shortest length of wood that will be needed to connect the peak to the main beam. So the distance from a line to a point not on the line is the length of the segment perpendicular to the line to the point. So what they have done is to do a construction, they've picked 2 points on the beam. So they've picked point R and S. Now they're going to do a construction, which means you take your compass and you put your pointed end on the R, and you're going to stretch it out so that it's at a point when you draw your arc, it's to a point south of A. Using that same measurement, the same width that you've got for R, you're going to put the point on S, and you're also going to make another arc, and where they cross, it makes it perpendicular to point A. So the measurement AB represents the shortest length of wood needed to connect the peak of the roof to the main beam. Now it's time to check your progress. So which segment represents the shortest distance from point A to DB? Very good. We know it will be a line perpendicular from A to line DB, so it's going to be a segment AX. Now we're going to get into finding distance from a point to a line on a coordinate plane. This is going to require a whole lot more focus, and you're going to have to take really good notes. I'll break it down step by step. First of all, we've got line S, and it contains point 0, 0. And it contains point -5, and we're to find the distance between line S and this point. Well, from our first example, we know that the shortest distance is perpendicular line. So what we're going to have to do is, what steps are we going to take to find the distance of that perpendicular line? So the first thing we need to do is find the equation of the line by first finding the slope. So step 1, you might note that you're going to find the equation of the line by first finding the slope. So we're going to find the slope of line S. And you've been doing that quite a bit, so that's pretty simple. Now the next part of step 1 is then we're going to write the equation of the line, and we're going to use this slope-intercept form. We're using that point 0, 0 that was on the original line in order to find where it crosses the y. So the equation of the line is y is equal to, the slope is -1, so -x plus 0, but they've left the 0 off. So step 1, we find the equation of the line by A, finding the slope, and then B, using slope-intercept form. So make sure you have that written in your notes. You're going to need that to solve your homework assignment. Step 2. Step 2 is we're going to write an equation of the line that is perpendicular to the first line and goes through a specific point. Now we're told that it's perpendicular line T is perpendicular to line S and goes through point 1,5. So since the slope is -1 for the line S, we know that line T is the opposite reciprocal, so its slope is 1, and we're going to write an equation for a line T with a slope of 1 going through 1,5. Using slope-intercept form, we're substituting a 5 in for y and a 1 in for x. We know the slope is 1. So it crosses the y-intercept is 4, so the equation y is equal to x plus 4. Okay, so we found the slope. We've written an equation and then written the equation of that first line. Then we write the equation of the second line that's perpendicular. Now we're going to solve a system of equations so we can find out where those two lines intersect. So there are the equations of the two lines. We solve for y. Now we substitute back into one of these original equations so that we can find out, we're going to substitute in for this one so that we can find out that x is -2. So we know that the point where the intersection is at a -2, 2. They're labeling this point Z. Now we're going to use the distance formula to go through that one point we know that what is perpendicular to the line and the intersection point. So use the distance formula to determine the distance between 2 points, and they're 2 specific points. The point that we started with and their intersection. We use the distance formula, which we've done quite a bit. We find that the distance between the point and the line is about the square root of 18, or about 4.24 units. If you go ahead and find out what the square root of 18 is 4.24 units. So time to check your progress. Now this one will be a bit of a challenge, but you use the same steps. If you take good notes from before, you can solve this one. If you have any questions on it, you'll be sure and ask me tomorrow, and I'll work this problem out for you if you can't get the right answer. Okay, the square root of 8, or about 2.83. So first of all, you had to find the equation of the line. So you found the slope of the original line, wrote it in slope-intercept form. Then you had to write the equation of a line that's perpendicular to the first one using a specific point, solve your system of equations, and then use the distance formula. So if you did all of those, you should have gotten the right answer. Next, we're going to look at the distance between parallel lines. The distance between two parallel lines is the perpendicular distance between one of the lines and any point on the other line. So first of all, we're going to find we've got the equations of these two lines, and we need to find the distance. The shortest distance is a line that's perpendicular. This one also has steps that you need to notate. The two lines are equidistant from a third. Equidistance means that the distance between the two lines measured along a perpendicular line to the lines is always the same. So these lines are equidistant from each other. It doesn't matter what line that you put between the two, it's going to have the same measurement. Okay, so we're going to solve a system of equations to find the endpoints of this segment. We've got to see where they intersect. So we found the slope of P is 2, so its opposite reciprocal is -1/2. We're going to use the y-intercept. I just picked the y-intercept of one line and substitute it into point-slope form. And solve so that we can find the equation of that line that is perpendicular. Now we're going to use a system of equations, so we're using line A and the one that we drew, the new one, line P. We're going to substitute in group-like terms and simplify. So the points of intersection, and this one doesn't come out so pretty, and neither will the one on the exercise that you do next. So a lot of times when you've got parallel lines, they don't exactly match up point to point. So you're going to have some that look a little off like this. So don't be worried. Then you're going to use the distance formula in order to find the distance between the 2 points. And this one's approximately, that's what this squiggly line means. the squiggly equal sign, approximately equal to 1.79. Okay, now time to check your progress. If you have difficulty with this one, check with me tomorrow and I'll work on it for you. Did you get 2.85? You had to do a little rounding. I got 2.84604 when I did my rounding, 2.85. Excellent job, and you're ready to begin the assignment. Make sure you have your notes, your a summation, and then a question for you to ask me tomorrow.